In this video, we are going to be talking about lesson 8.7 of honors chemistry, that is stoichiometry. There is 8.6, which we did kind of skip over. It's empirical and molecular formulas from present composition. So I do want to quickly go over that. You have to convert the mass into 100 grams, convert to moles, divide by the smallest amount of moles, multiply the reciprocal to remove any fractions. It's very simple stuff. So we're going to be focusing our attention on stoichiometry instead, because I just think that, oh my God, Ross Bernstein just followed me. That's funny. That is funny. So you'll have to do at worst 3 steps. Convert to moles, switch to a new moles, and then convert out of the unit. I will say grams is always the hardest unit because you have to go to your periodic table and then actually, look at the ratio. Particles is always going to be 6.02 times 10 to the 23rd. Liters is always going to be 22.4 liters for volume. So you have to balance the chemical equations, drop the coefficients below the chemical formulas, place the given information above the formula, place an X above the formula you're solving for, blah, 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 blah. Here's an example of stoichiometry, the hardest type. We're starting, if we need 8.2 grams of KClO3, how many grams of KCl produced? You need 2 KClO3, 2 KCl3O2. Yes, I know I'm going on a trip tomorrow. I have to go to bed in about an hour, which is crazy given that it's only 7:58. But I figured that people actually might need this video. That's why I'm making it. But, yeah. So 8.2 grams of KClO3 over 1. To cancel out the KClO3, we put KClO3 on the bottom at 122 grams because that's how much is in 1 mole. We need to put the actual substances in here because it's going to change throughout the problem. So this whole unit matters, and I was not doing a very diligent job checking that, and this is my punishment. So mole KClO3 goes on the top and bottom. You do need to show the 2 over 2 for the dimensional analysis purposes. You do need to show that part over there, even though it just leads to 1. You can cross off the 2's if you want to, because, you don't need them, but you do need to show that stoichiometry in there. You do need to show that you're changing from mole KClO3 to mole KCl, and it's not always going to be 2 to 2. Then 74 grams of KCl, it's going to be 1 mole of KCl, so you can cross that off. Then you multiply the top by the bottom, and you get 4.97. Again, rounding to the amount of significant figures they give you, 8.20, so they give you 3 significant figures. So your final answer should also have 3 significant figures, 4.97 grams of KCl. You're not notice that I didn't put the G in there beforehand. So I actually love this video because I get to correct my mistakes. This is another stoichiometry problem. Again, the hardest type because you have to find out the ratio. But it's not as bad with NaCl as compared to something like KClO3. Just not as bad. Now, this is liters. So you have 85 liters of chlorine. And how many grams of NaCl are needed? So you put that over 1. 1 mole Cl is 22.4 liters of Cl. This is chlorine gas, so Cl2. So I probably should have specified that, and I probably should just go in and, add a 2. That would probably be a smart idea. But yeah, I should actually really do that because if I don't do that, then it's technically this whole thing is wrong. And yes, that is the disturbing part of chemistry, is that if you make one small mistake, everything's wrong. Now, if your teacher normally does ever carry forward, but it's not always appropriate to do so in the circumstances. All right, so mole Cl, mole Cl2, forgot the 2 again, and you have 2 moles of NaCl on the top. This is when you're switching over into the different mole. 2 over 1 is, this has to be crossed off, and it's 58 grams of NaCl. Multiplying all that, you get 440 grams of NaCl. No decimal point because you only have 2 significant figures to work with. So, this is another stoichiometry problem that involves liters. start or end in moles, you subtract a step. So this problem only has 2 steps because you end in moles. This is a liter to liter kind of problem. So, in this case, by making it simple, you could cross off the 22.4s on the top and bottom. And then when you think about it, you have 600 divided by 3, so that's 200. And throwing in a 22.4 can really screw over your calculations. So I would recommend crossing that out. And of course, liters of H2, cross it with liters of H2. Moles of H2, cross it with moles of H2. Mole NH3, mole NH3. So that's, again, how you get all of that. Nice numbers to get to 200 with a decimal point after it. This is how many moles of water is produced if 24 moles of H2 is used. This is only a one-step problem. And, because moles to moles, you're subtracting 2 steps, so you only need 1 step. And this is something involving particles.